Good morning everybody and welcome today. Thank you very much for joining us and taking the time out of your day to learn more about the Stabicad product. So today's agenda, firstly we're going to go through some introductions, then I'm going to talk to you about the Constructible process and what that means to Trimble, what actually is the Stabicad product, and then I'm going to be handing you over to my colleague Ahmed Rayed for a workflow demonstration, and then we will wrap up with a short Q&A. My name is Brad Freeman. I am the Regional Sales Manager for Trimble MEP in the Middle East, and with me today is my colleague Ahmed Abdul Magid, and he is our Regional Solutions Engineer for a number of Trimble MEP's design solutions. We would like to make this session as interactive as possible, so please submit questions throughout this webinar. If you look for the question mark icon in the panel on the right, we will be able to answer these during the Q&A session. We'll have a couple of poll questions. Your responses are not public, so you won't be identified, but we would appreciate if you could answer them as we go through the webinar. What we've noticed in previous webinars is some people experience a loss of audio when we switch between the presenters. So if this does occur, please leave and rejoin. So let's start with the first poll question. Roughly what percentage of your projects are in Revit? Thank you very much. And one final question. How satisfied are you with your Revit productivity? Thank you very much. So, the Trimble Constructible process. Within the Trimble Buildings organization, there's an underlying philosophy that our products and services should enable a constructible process through being connected, content-enabled, and constructible. And this can be applied in the context of Stabicad with a provision of MEP content connecting all stakeholders through the cloud via Trimble Collect and constructible outputs through Stabicad. So what is Stabicad? Stabicad is a Revit integrated software solution that's been tailored with specific functionalities to improve the productivity and the efficiency of mechanical and electrical engineers and draftspersons. Within the software application, there's a host of modeling and coordination tools that include the likes of a palette center, which allows a user to rapidly design a mechanical or an electrical system. And Stabicad has a wide range of MEP content. This includes generic content, but it also includes manufacturer-specific content. And this is powered via MEP content. And if you simply log onto your browser and search mepcontent.com, you'll be able to access this at your leisure. And here you will see a wide range of our manufacturers' product catalogs. Stabicad also has integrated calculations for both mechanical system sizing and electrical network calculations. For engineers and draftspersons, there are challenges when they're using plain Revit. Creating a good quality MEP model is taking too much time. When elements are copied, they often lose important data, and this leads to a disconnected system. Sourcing highly accurate content is challenging. Companies have to spend a lot of time building and maintaining this content. Mechanical and electrical calculations are typically performed outside of the model, whether this be through a manual effort or via a third-party application. And when you factor all of it above in, there is a great risk of discrepancies within the design model and a disconnect between the model and the engineering calculations. So synchronizing design changes is typically a time-consuming manual effort, and this leads to a higher probability of costly errors. So why Stabicad? Well, Stabicad is going to make the engineer more productive. It's going to speed up the creation of the MEP model. It also maintains the metadata and the system connectivity within the model. And another key component is productivity. And productivity is being able to access high quality uniform content directly in the software. And this includes the provision of 3D families and 2D symbols. Integrated calculations within the model ensure synchronization when design changes occur. And this greatly reduces the probability of human error. And with Revit being an American product, it doesn't support the local norms our customers work with. And Stabicad allows the user to select the norms on a project-by-project basis. For example, many of the GCC countries use a version of BS calculations. We have this within the Stabicad application. And another key element is that we follow an open BIM policy. So what this means is that our content is fully parametric in plain Revit, and it's fully accessible to anybody that's not a Stabicad user. Through the use of Trimble Connect, Stabicad projects can be shared with all intended stakeholders via the cloud without any individuals needing to have licenses of Revit themselves. Now I'm going to hand you over to my colleague Ahmed Rayed, who's going to do a short presentation and demonstration on the workflow. Over to you, Ahmed.
Of today's workflow will be on the electrical design. However, many of the topics also apply to the mechanical design. So if you look at a schedule for MEP design on any project, these are some of the activities. First, you'll need to set up your project standards. These include project templates, settings and preferences, and a content library on a company level. Then you'll create the design BIM, most commonly in Revit MEP. After that, you will proceed with engineering calculations based on the defined loads in order to size the cables and containments accordingly. You would then specify certain manufacturers for the various components in the model, and as you develop your model, you would also need to coordinate the different MEP trades with the other disciplines on the project. So Stabicad enables you to fast-track this schedule by starting the different activities as early as possible, even if the full information is not available yet. Fast tracking enables you to have more overlapping activities and therefore a compressed schedule that meets your project deadlines. In the next slides, we will focus on each of these activities and how Stabicad enables you to accelerate them. So Stabicad is an application that runs on top of Revit and offers you many productivity tools to increase your efficiency across the various workflows. The core module of Stabicad is called Stabibase, and it's a hub that provides you with many features for company and project administration in one central location. With Stabibase, you can set up profiles to group multiple projects and apply the same preferences to all of them. These profiles can be by region, for example, type of project, or any other classification. Within a project, you can centralize your project folders, whether they are hosted on a company server or on BIM 360. And once the folders are set up, you can create new project files in Revit and also apply a selected template from your company standards. Stabibase also allows you to centrally manage the settings for your teams. So if I go to my drawing settings, I can centralize them either on a profile level or a project level, and I can choose from different categories of settings. So for example, for the electrical installation engineering, I can control the setting whenever I insert a new component, whether the family should be hosted by default, and what's my preferred mounting method. Similarly, for containments, I can centralize the settings, for example, the default height above the floor for all the containments that I model. From Stabibase, if you select a file, you can see a preview of the model and the file details. And if you double click on the project file, this will launch Revit to open the model. So with all these settings centralized by Stabibase, you're able to create a new project file as early as possible while working in parallel in refining your company level preferences and content library. Once you open the model, you can start using Stabicad to create your quick initial design. You don't need to wait to decide on which manufacturers to use content from. Instead, you can start creating a quick model with generic content from Stabicad. This content is provided and managed by Trimble, and the articles are rich with design data. This allows you to estimate the loads in various areas of your project and run your initial calculations for sizing the MEP services. As the model develops and as more information is available, you can replace the generic content later with manufacturer-specific content, either from Trimble or third-party providers. When you open a model from Stabibase, you can see that it launches Revit, and on the right side you can see Stabicad's palette, and this is where you can insert components into your model. Common tools are shown in purple, mechanical content in blue, and electrical content in orange. From the electrical palette, you can insert components for small power, be it distributors, outlets, or sockets, lighting switches, lighting fixtures, fire alarms, and other disciplines. For every component, there's a 2D symbol and an associated generic Revit family in 3D. The 2D symbols include both standards, CIBSE as well as IAC. And at the top you can see the Stabicad ribbon with various functionality for Stabicad Electrical, Mechanical, as well as the common tools. You can also access these tools from the palette if you prefer. So at this stage I would like to start adding generic components into my model. So I will open a plan and a 3D view to show you how that works. And I would like to add a generic distribution board on this wall. I'll head to my palette on small power distributors and select the right component. And I will start filling in the information. So the panel name is SB3. I would like the tag of the panel name to be visible. I will connect it to main panel MP, keep the visibility of the tag as no, and put it on circuit number 3. And then I will define the mounting height for this panel. You can see it's trying to add a 2D symbol on the plan and also insert a 3D family. If I change my placement hosting method to face-based, now it will load the face-based family, and all I need to do is insert the component and it will be placed both in 3D and 2D along with the tags for that specific component. I can now draw a generic lighting fixture, so I'll select it from my palette and I will place one as a template and then copy it to all rooms. I'll fill in the details, so this lighting fixture should be connected to panel SB3. I will override the visibility of the tag of the panel name. I'll put it on circuit number 1 and define the mounting height for this lighting fixture. And then I'll place it anywhere on the plan for now. I can then copy this fixture using Stabicad's tools, and the advantage of these tools is that they preserve the data on the copied elements, such as the panel and circuit, unlike the copy-paste functionality of Revit. So under Stabi Tools, I will choose the divider functionality, and there are different settings. A-A will keep the same spacing between the fixtures and the wall. A-2A will keep half the distance to the wall. So I will put 2 rows and 2 columns, and I will draw a rectangular area for my room. So now I need to select the element to be copied and then drag a rectangle around that room, and you will see that the components will be placed automatically at the correct spacing with the correct panel and circuit information. I'll go back to my template, and from here I will change the circuit to be circuit number 2, and once again I will use the divider tool one more time to put 2 rows and 2 columns, but instead of dragging a rectangular area, I will just select a space from the model, and once again you can see the elements have been put with the correct circuit data. And then finally I will select the template and change the circuit to be number 3, use the divider tool, but this time I will try the A-A spacing, and again put 2 rows and 2 columns, select a space, and now you can see the elements have all been copied at the correct spacing. I can now delete this template, and now if I tab through on the panel, you can see that all the elements are connected on the correct circuit for circuit 1, 2, and 3. So now I want to add a switch next to the socket. I can insert a new one, or alternatively, I can copy an existing one using one of the tools called Family Multiplier. So I'll copy by reference. It will ask me for the reference. It's this socket, and the element to be copied is the switch. And as you can see, it will look for the socket, and it has placed 33 instances. You can see one on the wall over here, along with all the instances of that socket. So now I've put all the components on one floor, including a panel, lighting fixtures, and sockets. I would like to copy all these elements to the next floor, which has the same architectural plan. So Stabicad enables you to copy all the elements while maintaining the panel circuit data. If I tab through, you can see the panel is connected to various fixtures through different circuits. I can select that panel and use Stabicad's copy panel functionality. First, I will verify which panel it is to be copied. These are the circuits on this panel, and I will press copy. Now all the elements connected to the panel and the panel are being copied. Now I can go to the floor plan of level 3 and paste those elements. And as you can see, all the circuits are maintained. The only thing I need to do is apply the correct name for the panel. So this is floor 3, and connect it to the main panel MP, and you will see that all the tags on the lighting fixtures are now reflecting the correct panel for floor number 3. So now that the electrical components have been added, I would like to model the containment. And at this stage, I only need the containments to be in the correct locations with accurate dimensions, regardless of the manufacturer. This is why I will use generic cable trays. So as you can see, I've already modeled some generic cable trays. I would like to add the trays to the 3 rooms we have been working on. So I will head to my palette under Cable Management and start drawing cable trays. For the product line, I'll keep it unspecified. And then I can proceed with choosing the dimensions, so the width and height for that cable tray. And I can start modeling it in the plan at the correct elevation. It remembers the default elevation from Stabibase. I can override this very easily. And then I can start drawing the cable trays. You will notice I'm not connecting them to the main tray yet, because I will do that for all items in one single function. So all I need to do now is put the 3 cable trays at the correct elevation, and then I will use Stabicad's tools for solving the node. I can either solve one node with options, or multiple nodes. So if I solve multiple nodes, I can drag a rectangle around all 3 nodes, and I will let Stabicad figure out the correct fitting to be placed, whether it's a 90 degrees bend or a T. And as you can see, I can select it in 2D or 3D, and the generic fitting for that specific node has been automatically placed for me. So now that the elements have been modeled along with the specified loads and the containments have been drawn, we are ready to perform the electrical calculations. So Stabicad enables you to run your engineering calculations from within your Revit model. Instead of using an external application, the integrated calculations within the model ensure that the model always matches the latest calculation outputs. The workflow starts with modeling the elements with specific loads, as well as the initial containments, and that's what we've done in the previous step. The next step is to let Stabicad auto-route the cables within the modeled containments. So as you can see, I've added some components to my model, and I will use Stabicad's tools to auto-route the cables. All I need to do is select the components and go to auto-route, and Stabicad will look at the components and the containments and do the auto-routing for you. So these are the auto-routing results. I can also show the routes on the model. So now I can see the cables going to the containment all the way to the panel. After the routing is done, Stabicad will run the electrical calculations for you and determine the cable sizes. So now if I go to calculate, it will use the integrated calculations engine to calculate the different circuits for you. So after it has finished calculation, it will show you any errors it has detected, if the cable's sizes have been changed. And if I select a component and go to edit final circuit, I'll also see the cable size that has been calculated as a result. I can also run reports from the integrated calculations. So if I go to the reports tool, I can choose from a variety of out-of-the-box tools provided by Stabicad and choose from the different categories. So for example, I can choose to run a cable report and show the cable analysis results. I'll select the cable and press OK, and now it will generate the report for me based on the cable analysis that was done by Stabicad. The same calculation engine can check your containment sizes and alert you if you do not have enough spare capacity. So now if I press calculate, it will load the calculation engine again, and it will alert me that I have 3 containments that do not have sufficient spare capacity, 2 cable trays and 1 bend. I can also click on the show button to show me in the model where exactly are those elements within my model. And to close the loop, you can go back and adjust the containment sizes accordingly and rerun the calculations. So as you can see, it's a closed loop cycle for an integrated workflow between your design model and engineering calculations. Whenever the information is ready, you can start replacing the generic content in your model with manufacturer-specific content. So now I've decided to select the manufacturers for the different components in my model, and I will start by selecting a distribution board from the available manufacturers. I will launch the MEP content browser, and this gives me access to a library of more than 600,000 manufacturer-specific content that is uploaded and managed by Trimble. All the content is in native Revit format, and therefore the models can easily be shared with all the stakeholders, even if they are not using Stabicad. When you replace a generic component with a manufacturer-specific one, Stabicad will preserve its properties such as the panel and circuit number. This way you can continue to build upon your existing model without losing the data along the way. So within the MEP content browser, I can start typing distribution board and choose the country where this component is available. Now it will show me all distribution boards available on our library for the UAE. Now I can narrow down by a specific manufacturer. So if I select ABB, it will show me just the components for ABB. I can hover over any of them and see the details, or I can click on the component and see the different article types provided for this board. And I can also load and insert that model directly, or alternatively I can download it to a company standard folder and make it available for all the users, which is what I've done here. So if I double click on the panel and if I go to product code, you can see that within Stabibase I've created for this project 2 panels from 2 different manufacturers, ABB and Eaton, and I'm allowing the users to choose from. For each of those panels, I can specify the description, the type, manufacturer, article number to start a procurement process, as well as the corresponding 3D Revit family, which in this case I have downloaded from MEP content. And that allows the users to simply go to a drop-down and select from the available panels that we use in our company. So if I select ABB and press apply, you will see that the correct Revit family will be loaded, and it will replace this panel in place without losing any data or any connectivity. So you can see the panel, circuit information, everything is still maintained, and the visual representation has been updated. So after I've specified the panel, I will then go ahead and specify the manufacturer for the lighting fixtures I had modeled. So I'll open the 3D and plan view, and I will drag a rectangle to select the 12 lighting fixtures I had modeled. So as I draw the rectangle, I can use the Revit filter to filter out the lighting fixtures. But you'll notice that Revit has found 15 lighting fixtures in my selection. And using standard Revit, the filter will not be able to drill down further. So in that case, I will use Stabicad's own filter, which is more advanced, because this allows me to go also into the family and type details and also select by floor level. So if I change my grouping and make it by category and family, now you can see that within the lighting fixtures, I actually have two families. One of them is the emergency lighting, which I don't need. So I can simply uncheck this from my selection. And now I'm left with the 12 lighting fixtures I had modeled. So another powerful feature by Stabicad. I can batch edit the properties for those lighting fixtures. And then I also have a light fixture code, which is similar to the power code. So with Stabibase, I can specify different lighting fixtures from different manufacturers, different powers, and let the users choose from. I can filter by any of these fields. For example, I can filter by the required power and simply select that element and hit apply. So this will replace all instances of the generic component with the manufacturer specific one. Once again, this is being done in place without losing any connectivity and only updating the visual representation of the components, and that maintains the panel and circuit information for you. I can also start specifying the manufacturer for the containments that I had modeled. So I will open the corresponding views I've created for the trays. And these were the trays we have just modeled for the 3 rooms. Now, if I select the tray, you will see that it's maintaining connectivity. So if I tab through, you can see everything is connected. That's a powerful feature within Stabicad. And then I can simply go to Stabicad Electrical and change articles in order to select the manufacturer for these cable trays. So from the drop-down, I can see the manufacturers I've downloaded to my Stabicad installation. I will select the specific manufacturer, and then Stabicad will tell me for the modeled dimensions, these are the product lines from this manufacturer. I can choose the product line and hit OK. And as you can see, the elements will be updated. Even the fitting now will take the exact fitting from that manufacturer. So if you select any of those fittings, you can see the manufacturer name, and you can see all the details provided by the manufacturer, including the article number for procurement process, and also the URL for that fitting. Once again, you can see all the elements are connected, maintaining connectivity even after they have been replaced. If I'm not happy with one of the fittings, I can simply delete it and once again use the solve node tool to let Stabicad put the node for me, but this time I'll do solve node with options. So when I drag a rectangle around that node, it will give me the possible solutions I have from that specific manufacturer. So I can see them in a 3D view, and I can choose to replace the horizontal bend with the adjustable elbow. And if I hit OK, now the new elbow has been placed, and as you can see, everything is maintaining connectivity. And again, that's one of the powerful tools of Stabicad, of always keeping the data and connectivity. You can see the details of the new fitting, the new article number, the URL for that component, and all the details that were provided by the manufacturer. So with the specification activity running, I can also start coordinating my designs earlier thanks to Stabicad's coordination tools. After I've specified the cable tray, I looked at the coordination view and I found that the cable tray is clashing with a round duct. So with Stabicad, I can very quickly generate a bypass to solve this conflict. So what I will do is I will head to my Stabicad Electrical palette and choose Solve Crossing. Now I have a scissor to cut the cable tray at 2 locations, and it will ask me what should the new elevation be, whether in absolute value or relative to the current elevation. So I can put it up to 100 at a 30 degrees angle and confirm the final values. And when I hit OK, Stabicad will automatically create the bypass, and it will insert the needed components from that specific manufacturer. So it's a very powerful and quick tool. And if I hit Tab, you can see the elements are still maintaining connectivity. If I would like to change the solution, again, I can delete those elements and solve node with options, and it will give me all the options available from that specific manufacturer. I can also start coordinating the builder's work and request openings for the various MEP services. So again, Stabicad provides you with a tool that streamlines this process. So if I go to openings for MEP, first I can define the default margins that I would like to keep around the different types of services and choose where the hosted elements are. And then I can start let the system automatically put the request for openings for me. So I will select the cable trays, hit finish, and then I will select the walls where I would like to request the openings. And then once I hit finish, you will see that Stabicad has placed for you the requests for openings. They are not voids yet, they are simply requests for openings that you can send to the structural team. You can see them in the 2D plan as well, and there's a full workflow for the structural team to review those openings and approve or reject them, and then finally create a void for you in the wall. Coordination also happens with other disciplines, so this is why we use Trimble Connect for other stakeholders who might not be using Revit. So within Stabicad, I can upload the model directly to the cloud on Trimble Connect. I will choose the correct server and correct project, and that will upload my Stabicad model to the open collaboration platform. So Trimble Connect is an open collaboration tool that connects the right people to the right data at the right time. It accepts most of the common file formats, including Revit, Tekla, IFC, and others. And Trimble Connect is included in the Stabicad bundle. You can access Connect from the Windows and mobile applications, or simply from your web browser. So I can open my Chrome browser and go to connect.trimble.com, and that will load the page where I can simply sign in from here. And once you sign in, you select the project, and you will see an activity feed of everything that's happening on the project. You can invite all the project stakeholders to start collaboration, even if they don't have any BIM authoring platform installed. You can set up teams and manage the team's permissions on the different folders. And you can easily set up the folder hierarchy and start uploading the project files. Any file can be uploaded, including drawings and BIM models from various formats. If you select a model, for example, you can see a preview for the model, as well as the file details and a full version history for that file. you can view or download any of the previous versions, or you can simply view the latest version. So that will open the model in your web browser, even if you don't have any of the CAD authoring platforms installed. So it gives accessibility for all the project stakeholders to be able to collaborate on the model and comment on any issues that they have. This is the model, the electrical model that we had created in Stabicad. I can see the specific lighting fixtures and cable trays we had modeled, as well as the request for the opening. And this is the elbow we had replaced. All the details from the authoring platform are available, and as well as the identity data that was put by Stabicad on that fitting, along with the article number, so again for procurement processes. And if I click on the URL that was attached by Stabicad, that will open the URL for that manufacturer providing this component. So right now I'm looking at only the electrical model. With Trimble Connect, I can federate multiple models for different disciplines. So for example, I can load the mechanical and electrical models and save them as a view. Alternatively, I can also load the structural model, which might have come from a different platform, and again federate all those models and create a view that is simple for everyone from their web browser to view, cut sections, annotate, and measure dimensions. With the federated models, you can run clash analysis as well. So you can see I've run a clash analysis between the electrical and structural disciplines. I can view all the clash results. If I click on a clash, I can see the clashing elements, isolate them, and take further action. So for example, I can create a task, which in Trimble Connect we call a to-do. And that way we can collaborate with other teams. So these are all the to-dos that have been assigned to me. One of them is already closed. So if I click on that to-do, you can see that there used to be a clash between a cable tray and the beam, and that has already been resolved. This is why the to-do is closed. I have a pending to-do requesting wall openings. So this is the one that we have just done with Stabicad. So now I can mark this issue as closed, and I have one more to do assigned to me where we need to put a wall opening for this cable tray, and once again I can use Stabicad to do that. So this concludes the technical demonstration, and over to you.
Thank you very much for that, Ahmed. That was very informative. So, within a Stabicad subscription, you have access to all MEP functionality. This is not a modular solution. Everything we own, we would add into a license. So, electrically, we would have a full suite of the ProDesign 2D software application. So, for those who are familiar with the ProDesign software, this is also included within the Stabicad subscription. You have access to all of the high quality MEP content, both manufacturer specific and detailed generic content, full suite of the integrated calculations. All of our licensing is network license as standard, which means you can install this on as many machines as you require, with a set number of users being able to use this at any one time. A license to our Trimble Connect is also included within the license. You get all of our updates, which are between monthly and quarterly, and you have access to a very experienced support team. So before we go into to a short Q&A, I would just like to summarise the component parts of a Stabicad Electrical subscription. So all of the function that we have electrically enables the full workflow for Revit projects, but it also provides access to the ProDesign applications as explained in the previous slide. And there's a lot more functionality in the subscription bundles with a much more reduced cost compared to our previous perpetual licensing model. So for existing ProDesign customers, you can easily switch from your existing ProDesign license to a Stabicad subscription. This includes, as we mentioned, all of our ProDesign 2D application, and this is the ProDesign 400, so this is our highest tiered design solution. Also the Protect HV, so for any LV, HV gradient and discrimination studies that need to be carried out, you will have this solution available to you. Also the HV fault level calculations and the single cable solution. Then Stabicad Mechanical also offers the full range of mechanical system design and sizing calculations, and within that is also included a number of applications and productivity tools. This includes the MEP openings, the ability to import and export from Excel if you would like to make global changes within the model. And before we go into the Q&A, we've got one last poll question. Would you like any more information on the Stabicad? Thank you very much for all of your answers, appreciate them. So now we're going to move into a short Q&A. I can see there's been quite a few questions. Unfortunately today we won't be able to get through all of them, so any questions that we do not answer today, we will come back to you very shortly with your answers. So, Ahmed, can you hear me?
Yes, I can hear you.
Perfect. So the first question is, can I use Stabicad with my own Revit templates?
Yes, so Stabicad offers a standard template. However, if you have your own Revit template, we will work with you to merge both templates together. So we basically just add a little bit more information to your own template so you can continue to use it with Stabicad and leverage all its functionality.
Great, thank you very much for that, Ahmed. And another question, will Stabicad work with our custom families?
Yes, as well. So if you have electrical and mechanical custom families that you have already built, or maybe you have downloaded from a third party, you can still use these with Stabicad. So basically we offer you a tool that injects the correct parameters to these families, and then you can use those with Stabicad.
Great. What versions of Revit do you support?
So at the moment, we support Revit 2019 through 2022. So we always support the latest 4 versions of Revit.
Great, and we'll finish off with a couple more. I can see there's quite a long list, so we will have quite a big task to go back. Thank you very much for all your questions. We appreciate them. For the openings request, can we use it to create a void in the wall?
Right, so the answer is yes. There are, let's say, 2 versions of the openings request tool. There's the version that the MEP team will be using to request the openings. And then there's a free version that the structural team can download. And they can use that tool to review all those opening requests. And for the ones that they approve, they can create a void and then send you the updated structural model.
Great, and a final question, does Trimble Connect work without an internet connection?
Yes, so Trimble Connect has multiple interfaces. So one of them is Trimble Connect for Windows, another one for Trimble Connect for mobile on the Android and iOS devices. And both of those allow you to download the models and store them on the offline storage. And that way you can use those models while you're offline. And then if you do any changes on the field, once you go back to the office and you have an internet connection, you can synchronize.
Perfect. Thank you very much for the answers there, Ahmed. Very informative. So at this point, I would like to say thank you very much for joining today's webinar. We hope you found it informative. Should you have any questions you would like to speak to us directly, please feel free to email myself, or feel free to email Ahmed, or give him a call if you have any more questions or queries on the product. For those who've asked questions that we've not answered today, we apologize, but we thank you for your questions. We will come back to you shortly with the answers. And yeah, please look out. There will be more webinars following in the coming months, so please look out for them. Thank you very much for today. Enjoy the rest of your afternoon. Goodbye.